Okay, part 1. Block is on horizontal ground, and we've got some forces. 14.7 newtons going straight down. It's not mass. R, and when the 4.9 force is applied horizontally, so that's 4.9, it's in limiting equilibrium. So we've also got friction going back here, and that's it. And it's limiting friction, which equals mu r. So solve horizontally. That says that F equals 4.9, and resolve vertically. It says that R equals 14.7, and so we want to find out what mu is F over R, which is 4.9 over 14.7, which does equal a third, which is what they wanted. Part 2. And now it says on a diagram like so, and the force is now at an angle like so, and that bit is 30 degrees. What are the forces? I've obviously got the 14.7 straight down. I've got R, which is a different R to we had before. I've got friction going back like so. And this time the block moves across the floor. I've got the limiting friction again, but a bit of acceleration at this stage. And what we've got to calculate, the first thing is the vertical component of the contact force between the floor and the block, and the magnitude of the friction force. So A, I'm going to resolve vertically, and that would say that R plus this component here, which is 4.9, so plus 4.9, and that will be sine 30, and that equals 14.7. So it says R equals 12.25 newtons, and now we got F lim, which equals mu R, which equals 1/3 times by 12.25, which equals 4.0833. 3 squaring. That's done part 2. A, I've worked out the contact force between the floor and the block. That's the R, and the magnitude. Right, now for part B, I need to work out the acceleration of the block. Okay, part B, I need to work out the acceleration of the block. So that means I need to resolve horizontally, and that would say that resultant force equals the mass times acceleration. So to the right we're going to take, so that'll be 4.9 cos 30 minus the friction, which is worked out is 4.0833, and that will equal the mass times acceleration. But we don't actually know what the mass is. We know that the weight was 14.7. So 14.7 is the weight, which is the force, which is the mass times acceleration, and mass times g in this case. So the mass will equal 14.7 over 9.8, which equals 1.5. So this equals 1.5 times the acceleration, and so the acceleration also will be 0.16019 equals 1.5a, and so the acceleration equals 0.107 meters per second squared. And now part 3. We've now got similar to before, but now the force goes at 30 degrees to the vertical. So that's my 4.9 force coming here, and I've got the weight still coming straight down, which is why I'm going to write it down as 1.5 g. Up is R, friction to the left like that. And now I've got this being, that is my 30 degrees now. I've got to work out what's going to happen. Definitely going to have to find out what R is. And so I'm going to resolve vertically. And that will give me that R plus 4.9 cos 30 equals 1.5 G. That gives me that R equals 10.45647. That's what R is. And we know that F is less than or equal to mu R. So what I need to do is find out what F equals, and we need to see what this component of the force is here. So the horizontal component is 4.9, and that'll be sine 30, which is 2.45 newtons. We know that F has to be less than or equal to mu R, so F has to be less than or equal to a third, because that's what mu is, times R, which is 10.45647, and so F has got to be less than or equal to 3.48549. But so F is less than that, but only 2.45 newtons to right, and therefore F will equal 2.45 newtons to the left. It doesn't need to get any bigger than that, or else the whole thing would move to the left, and that can't possibly happen. So they'll balance each other out. There will be no acceleration. It won't move because friction can go all the way up to 3.48. It only needs to go up to 2.45 here. As if it really has a mind. But hopefully you know what I mean. That's 6 done.